Hello? Yeah. Hello, everybody. Welcome back. Let's get started with the second season very quickly because of the time. I want to present the first speaker, who is Tamara Sánchez. She is going to talk about antagonist effect of nematophagous fungi against pine wood nematode, Burchapelensis xylophilus.
Okay, good morning, everybody. First of all, thanks to the Congress organizers and all the colleagues for their help. As Christina said, I am going to talk about the nematophagous fungi that we can use against pinewood nematode. It is a part of one of the Leonardo grants awarded in Spain in 2020 and funded by BBVA Foundation. Before starting with the explanation of my essay, I want to present the disease, the distribution, and symptoms. So, pinewood disease affects coniferous forests worldwide, and it is caused by Burchapelensis xylophilus, commonly known as pinewood nematode. This nematode colonizes resin canals of the tree and feeds on the cells and causes wilting and the final death of the tree. It is very important to emphasize that the nematode can only be transported by water or by an insect vector. And in our case, it is the second option. So they need an insect to enter the trees. And this insect is mainly in Europe, Monocamus galloprovincialis, that it is a therambithid that feeds and lays the eggs on wood and pine twigs, and these are the two ways in which the nematode can enter the tree, so by feeding or by oviposition of the insect. About the distribution, this disease affects North America, Asia, Ukraine, South Africa, and Portugal. And nowadays it is not a serious problem in our country, but it's very important to prevent for becoming so. And about the symptoms, as we can see in the picture below, it begins with the yellowing of some of the branches, and it finishes with the death of the tree. So far, the first entomology group of our university has already found and patented methods to control the insect vector, only the vector, by using Bovaria species that are entomopathogenic fungi, so fungi that can kill the insect. But we need to find an integrated management method to control not only the insect, but also the nematode, which is the real pathogen. And that said, I want to present concretely my essay, which aim is to test the efficacy of different nematophagous fungi to reduce the nematode population. First of all, I want to show you a short video in which we can see how the fungi epiphyte trap the nematode. Okay. Regarding the material, we use the strain CSFN1 of the nematode, grown on these vials with barley. Then we have 6 different treatments that were tested, 3 Bovaria species, 2 Trichoderma species, and Talaromyces ruber. We have 2 other treatments that we use as indicators of null and high ground, respectively, that were Stella vermicola and Botrytis cinerea, and a control with the culture media that was PDA. We prepared these vials with autoclave barley and pour inside 3 mycelium plaques of each fungi or culture media in case of the control. And we poured 100 microliters of the nematode suspension. a total of 270 nematodes. 5 replicas were set for each treatment, and we maintained them at 25 centigrades in dark during 15 days. And after these 2 weeks, we extracted the nematodes and carried out 3 counts of each replicate, so that at the end we have 15 counts of each treatment, and we calculate the average of the population size. And actually, we got promising results, because as you can see in the table, with the first 4 treatments, the growth of the nematode population was 0, so there was no reproduction. And with the other 2 treatments, the growth was lower than with Botrytis cinerea. An important point to remark here is that we got unexpected result with Stella vermicola that was supposed to be a nematophagus fungi, but the growth is actually high, and it could be due to the absence of this kind of spores, that was lunate spores, which are the structures responsible of trapping the nematode. And especially interesting are the treatment with Boveria bassiana and Boveria pseudobassiana, because if you remember, they are the fungi responsible, the fungi that we use to control the insect vector. That means if we prove that these fungi are indeed effective against the nematode, we could use exactly the same fungus to control the vector and also to control the pathogen that is the nematode. And to finish the presentation, I can state that Boveria bassiana and Boveria pseudobassiana are effective in suppressing the reproduction of Bursaphelenchus xylophilus, that Trichoderma citrinoviridae has also an inhibitory effect on its reproduction, and that the use of Boveria species for an integrated management of the disease would be the ideal choice, since based on in vitro conditions seems to be entomopathogenic and also nematophagus fungi. So in other words, they could control both the vector and the nematode. And just said that we have only carried out in vitro experiments, and we need to confirm them with in vivo experiments, so using the insect, not only in these vials with control conditions. And that's all. Thank you very much for your attention.